Most people have quietly accepted a very strange compromise. Beat. You pay $20 every month for an AI that monitors you.
Yeah, it actively tracks your daily work.
It routinely slows down during peak hours, too.
And it sends your sensitive thoughts straight to a corporate server.
Right, but Google's release of Gemma 4 shattered that dynamic entirely.
Absolutely. The era of renting intelligence from the cloud is officially over.
Welcome to the deep dive.
We have a lot of ground to cover today.
Today, we are analyzing the reality of Google Gemma 4. We are looking at why running a massive model locally changes everything.
And we will break down the mechanics of installing it yourself.
It really is about true data sovereignty.
Yeah, it is a free model you run on your own hardware.
Let's unpack the foundational philosophy behind this shift first. Why does moving computation to your desk actually matter?
Because it completely eliminates the middleman from your workflow.
Wow.
You are no longer relying on a constant internet connection.
Or paying those endless monthly subscription fees.
Exactly. When you use cloud tools, your data is the product. Your proprietary code or your financial spreadsheets get ingested by their servers.
But Gemma 4 runs purely on your local silicon. That represents a massive philosophical pivot for personal computing.
It really does. You aren't just querying an oracle anymore.
You literally own the oracle.
Right, and you are finally liberated from infrastructure bottlenecks. When the globe logs on at 9 a.m., cloud models throttle you.
With Gemma 4, your speed is dictated only by your hardware. It also features incredibly robust multimodal capabilities.
Yeah, you can feed it text, images, and raw audio directly. Now you can drop a complex text document right into the chat.
And ask it to extract specific line items.
Or explain really anomalous data trends.
2-sec silence. Whoa. Imagine having that kind of raw reasoning power totally offline. It fundamentally redefines what a personal computer is capable of doing.
It absolutely turns your machine into a secure reasoning engine. You never have to worry about API usage bills again.
If it is free, what stops Google from collecting the data anyway?
Well, it physically runs on your hard drive. The data never actually leaves your machine.
Right, so your private data genuinely never leaves your laptop.
Exactly. But you can't just cram a massive model onto an old laptop.
The critical choke point is your machine's active memory. Think of RAM as your computer's short-term memory.
Yeah, get the match wrong and it barely moves. The system has to load billions of mathematical weights into RAM.
If you lack memory, the entire system grinds to a halt. That is why Gemma 4 comes in 4 distinct sizes.
Right. The smallest versions are the E2B and E4B models. The E2B model operates smoothly on just 5 gigabytes of memory.
And the E4B requires roughly 8 gigabytes of RAM. That one is the recommended starting point for most users.
It is the absolute sweet spot for balancing logic and hardware. It fully handles text, images, and audio processing.
Then we cross into the heavier compute tier with the 26B model.
This requires 16 to 20 gigabytes of unified memory to run properly, but it utilizes a complex mixture of experts' architecture.
What does that mean in practical terms?
It's like a team of small experts instead of one brain. Instead of activating the entire massive brain, it selectively fires.
It uses a math expert for calculations and a writing expert for linguistics.
Exactly. It punches way above its weight class for logical reasoning. Then we reach the flagship 31B large model.
That requires 32 gigabytes of RAM and a dedicated GPU. It is for pro tasks and deep analytical reasoning. What exactly happens if I force the 31B model onto my 8GB laptop?
It will completely choke, the responses will stagger out painfully slow, or it will just freeze.
So picking a model that's too big ruins the whole experience.
It really does, so you should definitely test drive it first.
Downloading a massive file to test its writing style seems inefficient.
Right.
You want to verify that the logic aligns with your workflow.
Thankfully, you can evaluate the 26B model online right now. You can access it through Google AI Studio in your browser.
You bypass the heavy local hardware requirements entirely for testing.
You just navigate to the AI Studio dashboard. Ignore the overwhelming right panel with all the developer settings.
You simply switch the model from Gemini to Gemma 4 26B.
From there, you interact with it naturally in the chat window. This is the ideal environment to test its visual processing.
You can upload a photo of a messy, handwritten grocery list.
And ask the AI to categorize items into dairy, veggies, and snacks. It handles overlapping ink and terrible handwriting with shocking accuracy.
Does testing it online accurately reflect how it'll feel locally?
Yes. The logic is identical, it just saves you the initial massive download time.
It's a perfect test drive before committing your hard drive space.
Exactly. So how do you actually get it on your computer?
Most assume you need a computer science degree for this. But today, you just need a dedicated environment called Ollama.
Just like you need VLC to play a movie, you need Ollama to run an AI model.
It packages the incredibly complex backend into a clean, unified installer.
The installation process genuinely takes under 3 minutes now. If you are on Windows, you download the executable file.
You click Next and look for the Llama icon in your taskbar.
On a Mac, you unzip it and drag it to Applications. You just click Open to trust the app.
Linux users simply paste a single curl command into the terminal.
The script autonomously fetches the right binaries and configures everything. Once Ollama is running, you download the model inside the app.
You just type Ollama pull Gemma 4.E4b into your terminal.
And you can type a llama list to verify the download worked.
Is this really as simple as installing a web browser?
Absolutely. The installer handles all the heavy lifting behind the scenes automatically.
So you really don't need to be a developer to install this?
Not at all. So the model is installed and blinking at you.
How do you make it actually useful for everyday tasks? You have to provide highly specific contextual boundaries.
Vague inputs mathematically guarantee generic hallucinated outputs. I still wrestle with prompt drift myself, getting lazy with my instructions.
It is a very easy habit to fall into. You don't just ask the model how to start gardening.
Right. You say you have a small balcony with 4 hours of sun. Give me 3 easy vegetables and pots and watering schedules.
By constraining variables, you force the algorithm to filter out noise. It works beautifully for complex logistical planning as well.
I mean, planning a multi-stop Monday to save gas is a great example. You have a school run at 8 a.m., a meeting at 10 a.m., gym and groceries.
It gives you the most mathematically efficient driving route. It is also a profoundly capable tool for independent learning.
You can ask it for HTML, CSS, and JS for a to-do list in a single file.
You save it as index.html in Notepad, and you have a working offline website in 2 minutes.
It bypasses the entire nightmare of configuring local servers.
Why does putting the code in one file matter for a beginner?
Because you don't need to link multiple files together. You just double-click and it works.
It completely removes the friction of learning web development setup.
It really does. But what happens when you push the AI with hard logic?
This is where we hit the edge of language model architecture. They are not actually reasoning, they are calculating probabilities.
Right. So let's look at the 100-student bus and van puzzle.
You have different capacities and costs, and a strict no empty seats rule.
The AI might hyper-focus on cheapness and forget the no empty seats constraint.
It commits to an answer before doing the sequential math.
Exactly. You can fix it by correcting it in plain language, but the real trick is humanizing the tone first.
You can ask for a cookie recipe using cold butter, but told in the warm tone of a grandmaster chef teaching a beginner.
It completely shifts the response from a sterile list to an engaging lesson. For logic puzzles, you use the magic chain of thought prompt.
You tell it to think step by step before you give me the final answer.
That phrase completely alters the token generation mechanism. It evaluates the van capacities out loud, catching the violation.
If it messes up the math puzzle, do I need to start a whole new chat?
No, just reply and tell it exactly which rule it broke. It course corrects.
Just treat it like a human and point out the exact mistake.
Exactly. Of course, running cutting-edge tech locally isn't always flawless.
You are running server-grade technology on your personal machine. Let's cover the quick fixes for the 3 most common roadblocks.
If the text generation is very slow, the model is too big. You should switch from the 26B model down to the E4B model.
Or you might just have too many background apps open.
The second issue is the dreaded model, not found terminal error. You have to check your spelling and tags exactly.
You must type Gemma 4.31b exactly as formatted in the repository.
Finally, users frequently break the multimodal image processing feature entirely. Make sure you aren't using a specific text-only download tag.
And you must use an app UI that supports image drag and drop.
Yeah, not just a basic text terminal.
Can I drag an image directly into my Mac's terminal window?
No, the raw terminal doesn't read image files. You need the Ollama desktop window.
Got it. Use the actual visual app interface for uploading your images.
Exactly. It handles the heavy lifting of translating the image.
Let's synthesize the journey we have taken today. Gemma 4 represents a massive paradigm shift in computing.
You don't need a massive server farm to have high-level AI assistance.
You don't need to pay $20 a month or have an internet connection.
Your data stays yours, and you dictate the rules.
The barrier to entry has completely vanished. We encourage you to go download the E4B model.
Start pushing its limits on your own machine today.
Give it complex constraints and force it to think step by step.
Push back on its assumptions and watch it course correct in real time.
Beat. If a private offline intelligence is sitting on your desk today,
Yeah.
how does that change what you're capable of building tomorrow entirely off the grid?